class, we will focus on the problem of cost assignment, which means that given a certain cost object, which can be a product, a service, a project, or an organizational unit, the objective is to assign the value of the resources which are absorbed by this cost object. Let's see the graphical representation of this problem. We have our cost object, and in order to define the value of the resources which are absorbed by this cost object, it is important to go back to the distinction between direct and indirect costs. So we have the direct costs, and these costs can be traced directly to the cost object. So we are talking about tracing. Why? The reason why is because of the definition of the direct cost, because we have that direct material or direct labor can be univocally assigned in an objective way to one unit of our cost object. If we think, for example, of a wooden table, we can know exactly the amount of wood that is absorbed in order to realize one table, and the same happens with direct work. So we can, in an objective way, assign the value of both direct material and direct labor to our final cost object. This is not the case instead in the moment in which we have indirect costs, that we can call them also overhead. In this case, if we have the overhead, by definition, they are absorbed jointly by more than one cost object. This means that we cannot assign their value in a univocal way to the cost object, but we need to allocate the value of the overhead to the final output. So we are talking about allocation. Allocation means that we are using a proxy in order to assign this value to the final cost object. So we are introducing subjectivity in order to translate, to share the value of this overhead on the final cost object. Let's see how this allocation works with a simple example. Assume that we have this situation. So we have a machine, in this case the circular saw, which is used both to realize chairs and to realize tables. Specifically, in the period that we are analyzing, we have the overhead that we want to assign, which is the machine depreciation, whose value is 90 euros. And the machine is used to produce 12 chairs, and we need 10 minutes in order to realize one unit. And at the same time, we are realizing 2 tables, and we need 30 minutes in order to realize one unit. This is the value of our overhead, and we want to share this value between the two different products. We need to allocate this resource. How? By applying a simple formula. We need to calculate what is defined as allocation coefficient. And the allocation coefficient is also known as K. Usually, we use the abbreviation K to talk about the allocation coefficient. And this allocation coefficient is that quantity that explains the relationship between the resource and the final product. The formula to calculate K equals the total value of the overhead that we want to assign, that in this case is 90 euro, it is the value of our machine depreciation, divided by the allocation basis, the total one, where this allocation basis is exactly the proxy that explains this relationship between the usage of the machine and the output that is realized. In this specific example, which is the quantity that explains the relationship between the usage of the machine and the final output, we can see from the data that we have that we can use the production time in order to explain the percentage of absorption of our machine by the two different products. We need the total allocation basis, which means that we need to calculate the allocation basis of the chairs plus the allocation basis of the tables. So we will have, first of all, the allocation basis of the chairs. We are producing 12 chairs, and we need 10 minutes in order to realize one unit. This is 120 minutes, which is the allocation basis of the chairs, plus the allocation basis of the tables. We are realizing 2 tables, and we need 30 minutes to realize one table. This means that overall we need 60 minutes in order to realize the 2 tables, which is the allocation basis of our table. If we divide 90 by 180 minutes, we can find 0.5 euro per minute that represents exactly the allocation coefficient. So we are saying basically that every minute in which the machine is used absorbed 0.5 euros of resources. So this allocation coefficient that can be written down here is 0.5 euros per minute. Once we are here, we need to finally assign the value of the machine depreciation to the two different products. So the formula goes on and says that if we want to assign the value of the overhead to the chairs, we need to multiply this k by the allocation basis of the chairs. So if you apply the formula, we will have 0.5 euros per minute, which is the same for all of the products, that should be multiplied by the allocation basis of our chairs, so 120 minutes. So we will have that the overhead of the chairs is equal to 60 euros. If we do the same with the table, we will have that the overhead of the table equals, again, our k, that is the same either for the chairs and then for the tables, multiplied by the allocation basis of the table. So we will have, again, 0.5 euros per minute that should be multiplied by the allocation basis of the table, which is 60 minutes. So we will have 30 euros. So if we look at the final result, we have that given the value of the overhead of the machine depreciation, by using an allocation coefficient, which is that ratio that explains the relationship in a proportional way between the usage of the resource and the final output, we can assign the value of our overheads to the two different products, which are the chairs and the table. So let's go back to the general rule. This is the allocation, so if we have the overhead, by using k, we can assign the value of the overheads to the different cost objects. But we can be even more precise, because if we need to assign the overhead, there are two different approaches that we can use in order to assign the value of the overhead. We can use what is defined as traditional costing system, or we can use another approach, which is defined as activity-based costing system, which is often abbreviated as ABC. What's the difference between the two approaches? In both of the cases, we are allocating the overheads to the cost object by using K, but if we have traditional costing system, we are just performing one time the allocation. While in the second case, if we have the activity-based costing, we are performing the allocation, so we are calculating the allocation coefficient twice, with a final objective to improve the precision in the allocation of the overhead. So that's the reason why, if we have an activity-based costing, we are trying to improve the precision in allocating these overheads, and we are talking about a cause and effect relationship, because we want to overcome the problem of assigning in a proportional way the value of the resources. And in the next two classes, we will see how a traditional costing system works and how an ABC approach works.